Welcome to today's session. Today in this session we are looking at Laplace, right? Now Laplace is also known as the equally likely approach. Equally likely approach. Okay, so what is it involved? So you are looking at, because you are uncertain of the outcome that is going to come. You are in an uncertain environment. So you are not really sure of the outcome that will occur. So you just assume that every outcome that is possible has an equal chance. Okay, there is an equal chance of either a good market or a bad market to occur. There's a good chance. There's an equal chance of you know it raining or not raining. In you understand, like if you cannot ascribe probability to a particular occurrence and you're in an uncertain environment, you have this particular approach, you are viewing your mindset is on equally likely. You just equal the probabilities. Okay, so what do we do? The first step is calculate the average of each alternative. Okay, calculate the average of each alternative, then compare them. You get the higher of their averages. Okay, alternative A, the average. We know that average is just the summation divided by the number of elements involved, isn't it? So alternative A involves 9 and 25. So 9 plus 25 divided by 2. While B involves 12 plus 30 divided by 2. And the other one is negative 18 plus 20, plus 50, right? Plus 50 divided by 2. Okay, then what do we get from here? Okay, we have 9 plus 25, which is 34. 34 divided by 2, that's 17, isn't it? All right. What about 30 plus 12? That's 42. 42 divided by 2, that is 21, isn't it? 21. Then we have 18, negative 18 plus 50. That gives us, should that be 32? What's that? Yeah, 32. 32 divided by 2, that's 16. Okay, so you compare your averages, because you've calculated your averages. Now you need to compare which one you pick the bigger of the averages. So you see that it is 21, which is bigger. So you choose investment or investment alternative B. Okay, so that is how Laplace is about. Now let's consider the last one, the Hurwicz criterion. Okay, what's about the Hurwicz criterion? In an instance where we looked at maximax, right, and maximini, where one was pessimistic, the other end opposite was optimistic, right? Now, optimism suggests that you just look at the best result. Okay, you just think that you're going to get the best result. Pessimism, you look at, okay, if I get the worst results, how can I be on a better point at the worst, right? That is about pessimism. Okay, now Hurwicz doesn't want you to choose in between. To choose either of the two. It suggests that you need to accommodate a balance of the two. Okay, you need to adopt a balance of the two. So it is basically a modification of the two. Okay, and by modifying the two, you create what we call the coefficient. what you call the coefficient of decision, right? All right. So that particular coefficient is described as alpha. All right. So that's coefficient of optimism is is denoted by alpha. So this particular coefficient of optimism is just basically a value between 0 and 1 that you feel like, oh, okay, the closer it is to 1, the more optimistic you are. Okay, the closer you are to 0. So if I say, I have a coefficient of optimism of 0.2, 0.2 is very close to 0. So meaning what you are indirectly saying is that the chance of happening is like 20%. You feel like, you know what, yeah, 20% is how I feel like, okay, this deal will be successful. And because of that, you use that as a coefficient of so you haven't really gone on 0 where you are totally pessimistic. There's a small portion of optimism because you are at 2, right? You can also say, okay, you know what, I feel like, okay, the good part can happen maybe 80%. So you have a 0.8 coefficient of optimism value. All right. Now, based off that, how then do we calculate? Okay, so let's take this simple formula. Let's take this simple formula so that we can address it. Okay, so and we do it for each investment. Okay, so the general formula is alpha, right, multiplied by maximum outcome pay plus, okay, alpha or 1 minus alpha. Let me just write that properly. 1 minus alpha multiplied by minimum. Okay, right? That is our that would be our general formula. So if we go for investment A, which is this investment that has a 9 and a 25. Okay, and let's assume, so assume as an example, assume that you have a 0.8 coefficient of optimism. Yeah, you have a 0.8. So how do you approach that question? So you have 9 and 25, isn't it? So you have a 9, yeah, you have a 9 and a 25. So you look at your formula, you bring down your formula, alpha multiplied by max plus, this is solution, right? Yeah, plus 1 minus alpha multiplied by minimum. Okay, so what is your maximum value there? And your alpha, you know that your alpha is 0.8. What about your maximum? It's 25, right? Plus 1 minus alpha, 1 minus 0.8 multiplied by, what is your minimum in that particular decision alternative or investment alternative? It is 9, right? All right. So then what would be the value here? What would be our value here? Okay, so we know that 0.8 multiplied by 25 will give us what? 20, isn't it? Yeah. Plus, what is 1 minus 0.8? We know that that is 0.2, isn't it? Multiplied by 9. And what is 9 multiplied by 0.2? that gives us 1.8. So 20 plus 1.8. So we have our answer as 21.8. So that is for investment A. What about investment B? So we bring down our formula, which is alpha multiplied by our maximum plus 1 minus alpha multiplied by minimum. Okay, for the investment B, what are the values we have? 12 and 30. Okay, 12 and 30. So we have the 0.8 multiplied by maximum, which is 30, plus 1 minus 8, that is 0.2, isn't it? 0.2 multiplied by minimum, it's 12. Okay, so let's see how that comes out. What is 0.8 times 30? So that will give us 24, isn't it? Plus 0.2 times 12, that is 2.4, right? 2.4, and that will give us 26.4. Okay, let us consider the last one. Let's bring down the formula as always. We have alpha multiplied by max plus 1 minus alpha multiplied by minimum value. So for the third investment, what do we have? For the third investment, we have negative 18. Yeah, this is 18. Negative 18 and 50. All right. So we have 0.8 here multiplied by 50 plus 0.2, which is 1 minus 0.8 times negative 18, right? What do we have here? 0.8 multiplied by 50 is gonna be 40, right? What about plus 0.2 over 18? 0.2 of negative 18, that would be negative 3.6. So negative times positive, that would be a negative 3, right? So then what do we have? We have 14.4. All right, then you compare this, your investment C, and this, which is your investment B, and this, which is your investment A. So what we are saying is you have 21.8, 26.4, and no, this one was, sorry, apologies, 40 minus 3, 40 minus 3.6, right? 40 minus 3.6, which is 36. This is supposed to be 36.4. Apologies on that one. Yeah. All right. We'll erase this one. So now, which one is the biggest amongst this? You realize that 36.4 is 36.4 is the biggest. Hence, your decision alternative or investment alternative that you would opt for is C. All right. So that is basically how we make decisions under uncertainty. All right. Maxi-max, maxi-mini, mini-max, regret, Laplace, and Hurwicz. So we've looked at all the 5. All right. See you in the next class.